Good morning, everyone. Today we are gathered here for going to take a case study on a overview of deep learning. As you know, deep learning is a subset of AI and ML, and it is inspired by the structure of a human brain. It uses artificial neural network with multiple hidden layers to learn pattern from the data. So in this case study, you guys going to explain how deep learning is used to detect phenomena for chest X-ray images. Start this session with a small intro of yours.
Myself Pradeep, and I'm going to speak about deep learning is why deep learning is important. Traditional machine learning requires manual feature extraction. This means human must tell the computer what patterns to look for. But deep learning automatically extracts important features from raw data. It improves performance when the data set becomes larger. It works especially when well for complex data like images, audios, and text. In our medical case study, instead of manually identifying infection areas, the deep learning model learns directly from thousands of X-ray images. This makes diagnosis faster and more accurate. Next will be explained by Priya.
So now I'm going to explain about the features of deep learning. So now I'll be listing out the important features. So the first feature is the automatic feature extraction. So here we don't have to do any manual work for extracting the feature. Instead, it will be itself taking by its automation. Then the second point is high accuracy. So this performs even with larger data sets. So it will be very easier when it comes to the applications of for example, let's say predicting disease with images. So there we'll be giving lots and lots of images, which is large data sets. So it will be giving high accuracy. Then the third point is hierarchical learning. So here it will be learning the simple patterns first. Only then it will be continuing with the complex patterns. And the next thing is scalability. So this can handle big data as we have already discussed. Then this has end-to-end learning, which means this takes the raw input and it will be directly giving the output by processing the data. So because of these features, so deep learning is very powerful in solving real life examples.
Good. For this case study, what model are you going to use?
So for this case study, I've used a model called a CNN, which is a convolutional neural network, which is also known as CNN. So this is basically designed for recognizing the images and which is used for image processing task. So it has mainly three layers. One is the convolutional layer, then the pooling layer, then the fully connected layer. So convolutional layer is this detects features like edges and shapes. For example, if we have given a shape called circle, then it will be checking how many edges does it have and etc. So then it comes to pooling layer. So this reduces the image size so that the features can be extracted. Then the next layer is fully connected layer. So here this will be given the final prediction and the final output. So this for example let's say disease prediction. So here we'll be giving let's say skin disease. So here we'll be giving many symptoms images and this will be taking it and this will be processing in each layer and the final layer will be produced as the output.
But rather than CNN, is there any model available in deep learning? Any one of you? Rather than CNN?
RNN,
Yes.
GAN, auto input.
For this case study, we may use GAN or RN, maybe use. Is it possible?
We can use GAN.
GAN. What are the? Can you explain what is GAN?
GAN is a generative adversarial network. It uses it to find the real image or fake image. It has two types: generator and discriminator. Generator will generate the image, the real images. Discriminator is used to check it as the real image or fake image.
Yes, simply generator. What it gives only instant data of new data, and discriminator evaluates the what data gives by the generator. Can anyone tell you what are the process you've done with this case study?
For this case study, we have included the 5 steps of the process, ma'am. First step is data collection. We have collected around 10,000 plus data, the chest X-ray, the images were collected. And the second is data pre-processing. As we know, images were resized and normalized for the. We can't give the raw data directly to the modified. Then the third step is model training. CNN was trained using 8,000 images. We put the balance 2,000 plus images for a testing purpose. So for the fourth step is also testing. And in the fifth step, we used prediction, the system predicts normal or phenomena.
Okay, can anyone explain what are the advantages and where this case study is working?
Okay, ma'am. So deep learning is
Please.
Deep learning is widely used in many real-world applications. It learned complex patterns from large amount of data. In healthcare, deep learning models analyze data images such as X-rays, CT scans, and MRI scans to detect diseases like cancer, tumors with high accuracy. In computation, it used as a face recognition, object detection, and self-driving car vision system. So the advantage of the traditional machine learning techniques, one of the major strengths is high accuracy, especially in complex tasks such as image and speech recognition. So so many has the limitations. It requires very large data for effective training, and it may need in real world situations. Sufficient data may not be believed. Training deep learning models is computationally expensive and often require for powerful hardware such as GPUs or personalized process.
Learning is a powerful technology used in healthcare, speech, finance, and agriculture too. It provides high accuracy rather than machine learning. And also it learning automatically from the data. However, it requires large data set, high computation, and long training time. Despite limitations, deep learning is transforming real-world applications and improving decision-making systems. So, thank you for your case study. Thank you, everyone.
Thank you.